Welcome back, students, to this lecture. In last lecture, we have seen digital TV recording techniques and digital display devices. In the digital display devices, one particular type OLED we have seen in detail. Now, in this second part, we will see LCD, that is liquid crystal display. Let us see what is actually LCD. LCD is a type of flat panel display which uses liquid crystals in its primary form of operation. LEDs have a large and varying set of use cases for consumers and businesses, as they can be commonly found in smartphones, televisions, computers, and monitors and instruments panels. We have seen LCDs in different instruments. Nowadays, LCD is present in all over the instruments. Means you can see the display in all the instruments, in mobile, in computer panels, in televisions. All over, LCD is being used for the purpose of display. LCDs were a big leap in terms of the technology. They replaced, which include the light emitting diode. Before, LCDs were used very commonly. After that, LCDs were replaced by the LEDs and gas plasma displays. LCDs allows displays to be much thinner than the cathode ray tube. Before, we were using CRT. After that, CRT was having a very large size. After that, LCDs were being used so that the size of the television set or the PC was reduced due to the LCD displays. LCDs consume much less power than the LEDs and gas displays because they work on the principles of blocking light rather than emitting it. Where an LED emits light, the liquid crystal in the LCD produces an image using the backlight. It means that we can say that liquid crystal displays polarize the light that shines through a sheet of glass on which deposited a liquid crystal array. Each pixel that changes the polarization to either pass or block the light. LCDs are used in front of the rear projectors. Large LCDs are used in flat panel displays. This is nothing but the LCD. LCDs, that is liquid crystal displays, are passive display technology. This means that they do not emit light. Instead, they use the ambient light in an environment. That is nothing but the LCD. By manipulating this light, they display images using very little power. This has made LEDs the preferred technology whenever low power consumption and compact size are critical. Liquid crystal is an organic substance that has both liquid form and crystal molecular structure. In this liquid, the rod shaped molecules are normally in a parallel array, and an electric field can be used to control the molecules. Okay, most LEDs today use a type of liquid crystal that is called as twisted pneumatic, that is TN. This type of liquid crystal is being used nowadays. A liquid crystal display that consists of two substrates that form a top bottle that contains the liquid crystal mixture. The inside surface of the bottle or cell are coated with a polymer that is buffered to align the molecules of liquid crystal. The liquid crystal molecules align on the surface of the direction of the buffering. For twisted pneumatic devices, the two surfaces are buffered orthogonal to one another, forming 90-degree twist from one surface to the other surface. This helical structure has the ability to control the light. A polarizer is applied to the front and analyzer reflector is applied to the back of the cell. When randomly polarized, light passes through the front polarizer. It becomes linearly polarized. It then passes through the front gas and is rotated by the liquid crystal molecules and passes through the rear gas. If the analyzer is rotated 90-degree to the polarizer, the light will pass through the analyzer and be reflected back through the cell. The observer will see the background of the display, which is in case the silver gray of the reflector. The LCD glass has transparent electrical conductors plated onto each side of the glass in contact with the liquid crystal fluid, and they are used as electrodes here. These electrodes are made of indium tin oxide, that is ITO. When an appropriate drive signal is applied to the cell electrodes, an electric field is set up across the cell. This is the diagram of the internal details of the LCD. As we have seen now, it consists of a polymer, electrodes, polarizers, glass, electrodes, perimeter seal, electrode, reflector, all these terms we have seen now. Then the liquid crystal molecules will rotate in a direction of the electric field. As you can see, all the liquid crystal molecules that are present inside that perimeter seal, that liquid crystal molecules will rotate in a direction of electric field. When electric field is applied, the incoming linearly polarized light that passes through the cell unaffected and is absorbed by the rear analyzer. The observer will see a black character on a silver gray background. When the electric field is turned off, the molecules relax back to the 90-degree twisted structure. This is referred to as a positive image refractive weaving mode. Carrying this basic technology further, using LCD having the multiple selectable electrodes and selectively applying voltage to the electrodes, a variety of patterns we can form here by using these techniques. The most recent advancement has been in the introduction of the film compensated super twisted pneumatic FSTN display. This adds a retardation film to the STN display that compensates for the color added by the effect. This allows a black and white display to be produced. Now we have seen introduction to the LCD and how is the structure, what is the structure of the LCD. Now let us see how does the LCDs work. In the LCD, display is made up of millions of pixels. The quality of display commonly refers to the number of pixels. A pixel that is made up of three subpixels, red, blue and green, commonly called as RGB. As we have seen in the first unit, RGB are three signals of the pixels. The pixels is made up of these three subpixels, red, green and blue. When the subpixels in a pixel changes the color combinations, a different color can be produced. Means R, G and B, these are the primary colors. This subpixels when changes the color combination, means we combine with each other in different combinations, so that when they combine with each other in different combinations, different colors will be formed. With all the pixels on a display working together, the display can make millions of different colors. When the pixels are rapidly switched on and off, when the pixels are rapidly switched on and off, a picture is created. LCDs are lit by a backlight and pixels are switched on and off electronically while using the liquid crystals to rotate polarized light. A polarizing glass filter is placed in front of and behind all the pixels. The front filter is placed at 90 degrees. In between both the filters are the liquid crystals, which can be electronically switched on and off. It means that there are millions of pixels and each pixels is having a number of subpixels, that is R, G and B, these three subpixels. These three subpixels are combining with each other with different combinations for forming the different colors to show on a display device. These all the subpixels are electronically switched on and off so that they can form different combinations within the fractions of second, and we can see different images within the fractions of within the seconds. Let's move towards the next point. Types of LCDs. Twisted pneumatic, as I told before, T and twisted pneumatic type of LCD is being used vast, which are inexpensive while having high response times. However, TN displays have low contrast ratios, viewing angles and color contrast. As discussed before, the twisted pneumatic TN, which are very inexpensive while having high response times. However, TN displays have low contrast ratio, viewing angles and color contrast. Next one is panel switching displays, IPS panels, which boost much better contrast ratios, viewing angles and color contrast when compared to TN. Next one is vertical alignment panels, VA panels, which are seen as a medium quality between TN and IPS displays. Advanced fringe field switching, AFFS, this is one of the type of LCDs, which is a top performer compared IPS displays in color reproduction range. These are the types of LCDs. Now let's see advantages of the LCDs. LCDs consume less amount of power compared to CRT and LEDs. LCDs are consist of some of microwatts for display in comparison to some milliwatts for LEDs. LCDs are of low cost, provides excellent contrast. LCDs are thinner and lighter when compared to the cathode ray tubes and LED. Disadvantages of an LCDs require additional light source, a range of temporary temperature in limit for operation, low reliability, speed is very low of the LCD, and LCDs need an AC drive for the performance. Means we can say that the LCDs have slim profile, they are 2 inches thick, their retail price is falling, they are very low price, and bright and sharp images it can provide, especially for video games or connecting to your PC to your home theater. It provides a bright and sharp images. And in disadvantage we can say they have limited screen size, they have poor back level, and images might not look as realistic as on a plasma television. Let us see some of the applications of the liquid crystal displays. Liquid crystal technology has major applications in the field of science and engineering as well as electronic devices. Liquid crystal thermometer, optical imaging. The liquid crystal display technique is also application in visualization of a radio frequency waves in the waveguides. It is used in the medical appliances also. Some of the displays you can see, that is LCD based displays, that is LCD monitor, LCD display camera, that is handycam, and LCD display smartphones also. These are some of the applications or uses of the LCD display. Let's see next display device, that is TFT LCD display or a monitor, where TFT stands for thin film transistor liquid crystal display. It has a sandwich like structure with the liquid crystal that is filled between two glass plates. As you can see in the image, there are two glass plates, and in between the liquid crystal is filled in between the two glass plates. TFT glass has a many TFTs as the number of pixels displayed, while a color filter glass has color filter, it generates the color. Liquid crystals move according to the differences in voltage between the color filter glass and the TFT glass. The amount of light that is supplied by the backlight is determined by amount of movement of the liquid crystal in such a way to generate the colors. Means in between the two glass we are having a liquid crystal. To determine the amount of color that is generated, we have to find the amount of movement of that particular liquid crystal. By the amount of movement of that liquid crystal display, we can find out how much color is generated, or in which way a color is generated by using that particular liquid crystal in the TFT. In the TFT, each pixel is an active matrix. It is paired with a transistor that includes a capacitor which gives each subpixels the ability to retain its charge. Instead of requiring an electrical charge sent each time it needed to be changed. The TFT layer that controls the light flow, a color filter displays the color, and top layer houses your visible screens. Utilizing an electrical charge that causes the liquid crystal material to change their molecular structure, allowing various wavelengths of backlight to pass through. The active matrix of a TFT display is in contrast flux and changes or refreshes rapidly depending upon the incoming signals from the control devices. Now, the pixels of the TFT display are determined by underlying the density, resolution of the color matrix, and the TFT layout. The more pixels, higher the details available in that particular picture. The available screen size, power consumption, resolution, interface, how to connect defines the TFT displays. In short, we can say about the TFT that TFT technology is a new standard nowadays. It is the manufacturers displays the monitors, laptop screens, and other devices. TFT LCD displays that can show crisp text vivid colors, fast animations, and complex graphics. The TFT LCD monitors, also called as flat panel displays, are replacing the old style cathode ray tubes as the displays of the choice. Almost all the LCD monitor displays take advantage of the TFT technologies nowadays.